right, here's our first example of graphing a rational function. So we'll be following these 7 steps below. So pause if you'd like. Here is our first example. We have a rational function f of x equals 2x minus 1 divided by x minus 1. So step 1 is we're going to determine if there is symmetry about the y-axis or the origin. So in the yellow box is the rule when we evaluate the function. If we evaluate the function for negative x and we get the original function back, we're going to have y-axis symmetry. Scenario 2 is if we evaluate the original function for negative x and we get a negative f of x and we have origin symmetry. So let's go ahead and do our test. We're going to evaluate the function for negative x. Then we simplify it. We get negative 2x minus 1 over negative x minus 1. We did not get the original function back, and we did not get a negative, so let's take out a negative. We did not get a negative and then the original function. So there is no symmetry. Step 2 is to find the y-intercept. So we've been graphing quadratics and polynomials. So it's going to be the same process in those two types of functions where we evaluate the function for 0. 0 minus 1, 0 minus 1, negative 1 divided by negative 1 is 1. So the y-intercept is over 0 up 1. Step 3 is to find the x-intercepts. So to find the x-intercepts, we set the numerator equal to 0 and solve it for x. So we're going to solve it for x by adding 1 and then dividing by 2. So the x-intercept is over 1/2 up 0. So 1 x-intercept. To find the vertical asymptote, we're going to set the denominator equal to 0. And solve it for x. So the vertical asymptote is at x equals 1. That's also where your domain restriction is. All right. Number 5, find the horizontal asymptote. So we're going to be looking at the degree of the numerator, which is 1. The degree of the denominator is 1. So the scenario we have is that both of them are the same degree. So we're going to be dividing by their leading coefficients. So we have 2 divided by 1. So our equation is y equals 2 is our horizontal asymptote. In the red, we'll cover that in another lesson. There are no slants. All right, question 6, or step 6, it says plot at least one point between and beyond each x-intercept. So sometimes you need to go and graph what you have so far and then go back and find this. So I'm going to go to step 7 and start to graph what I have. All right, so one of the things we found, so if we go back to the step 1, was there's no symmetry. We found the y-intercept to be 0, 1. we found the x-intercept to be at 1/2. There was a vertical asymptote at x equals 1. There was a horizontal asymptote at y equals 2. Now step 6 we didn't do yet. So what I'm going to do is I'm going to just go ahead and connect these 2 points. Now, if we think about asymptotes, asymptotes help guide the curve. So I'm going to go ahead and continue that green line running along the horizontal and vertical asymptotes. Now something else is probably going to occur either over here or down there. I'm not sure. So we need to find some additional ordered pairs. And how we do that is we evaluate the original function. So I'm going to go back up. So it says plot at least one point beyond each x-intercept and vertical asymptotes. So we're going to be evaluating the function. So let's say I let x equal -1. So we say f of -1. We're finding an ordered pair. And when we're done, we get 3/2. Now I'm going to evaluate it for 2. F of 2 simplify it and you'll get 3. We'll just do one more. All right, so there's our ordered pairs that we're going to graph. So one of the ordered pairs we found was -1 up 3/2 or up 1.5. So there's one of them right there. The next ordered pair we found was over 2 up 3. Then we found another one at over 4 up 2 1/3. So again, those asymptotes help guide our curves. So we just graphed this rational function by hand.